Taipei 101. So if you went to Taipei 101, or you go to Taipei, you plan to go to Taipei 101, you need to visit this. Did you visit? Anybody visit this? You did? You did? No? No? If you did not visit this system, means you really didn't go to 101, because that most important device when earthquake come in. The best place to go there, just nearby this. Okay? That's in 86th floor. So if you go to 101 again, don't forget, go to 86th floor. And to see this. And this is real sensitive, big mass there. You might wonder why I need a big mass there. This is well calculated. Why I need this big mass in there. And there's foot. I forgot how many foot, but I think it's a total of 4 or 6. And this, all the feet here, all total of 6 feet, so for example, 6 feet. Those are the damper. So earthquake come in, right? The frequencies of the earthquake in Taiwan is all below 15 hertz. So my design, the damper for this, and this is what I call the tube mass damper, like this. On the right hand corner in here, you can see there's a mass, and this is the mass. This is big ball is the mass, and the spring and dash part is in this each foot. Okay. The spring is tuned to the earthquake frequencies, so that they can oscillate. This mass can oscillate with the earthquake frequencies. And then, because they oscillate the earthquake frequencies, the mass will move. When mass move, means this 4 feet here will move. And these 4 feet will take up the energies, transfer from the earthquake to the building. That means this design will dissipate the energies that induced by the earthquake. Okay, so this mass, you cannot say randomly put any weight or mass there. This is well calculated mass. So you look at this design. This is in the 101. That's the design, one kind of design, very simple design. And do you know why they have 2 wire? See, you can see that there are 2 wire here. 2 wire there. Okay. 2 wire, right? If you look at the scale body, there's a wire there. Well, this wire try to at least to hand the ball so that it won't just put all the weight on this 4 feet. Because that's not the purpose. The purpose is that as long as this 4 feet move, then energy will be taken out from this tube mass damper. So this tube mass, this mass here, this spring, and this is we call the damping, the best part. The same thing. The equation for this system is exactly the same equation for this system. on the right hand corner, okay? And so we'll show you how you write the differential equation for this system so that you can design the tuned mass damper. Understand that? So I say 101 is safe, at least from this point of view. However, now it's earthquake, it's different kind of earthquake. Your earthquake frequency higher than 15 hertz, then you are out of luck. Right. That means control design doesn't just only solve part of the problem, doesn't solve all the problems. Okay. Now this is another design in the City Corp Tower. Now in the whole world, most of the building in the earthquake zone, then they do have this kind of called tuned mass damper in the building. However, now New York, they don't have an earthquake. Then why they do this? I mean, wind. Yeah, wind. Yes, because the wind. In New York, we don't really get earthquake. But 2 years ago, we had one earthquake. But those only 1 to 100 years. It's not as strong as like in Japan or in Taiwan. So their design for tuned mass damper is because of the strong wind in New York. And their design is a little different. And this is the old design. The 101 design is a new design. So this is the old design. But you can see that the old design, you can look at that, the same principles. You will use the same differential equations, but the design-wise, the devices, they are different devices. They have a different way. Right? That's the all kind of design available in the market these days. But again, they use the same differential equations, the same controller design, the same tuned mass, there are principles. Okay? All right, now, let's move to, I call slewing maneuvers. This is the design that when I worked in NASA about 20 years ago, probably more than that, 25 years ago. At that time, did you hear, you are too young, I don't think you heard anything about the Star Wars. You hear the Star Wars?